Chapter 4, Section 3, Polynomials. We're going to go through these terminology here of terms, types of polynomials, degrees and coefficients, combining like terms and evaluating polynomials and applications involving polynomials. First of all, terms are parts of an addition, really. So when we're talking about these monomials, really, or mono means single term, but a term is parts of the addition, and which is a little confusing when we're looking at a single term or a monomial, but it'd be like this plus 0, like this 3a squared b to the fourth power. Well, here the terms make sense as parts of an addition. 2l and 2w are terms of this expression. They're parts that are added together. In this case, it would be 5x squared plus x plus a negative 2. Negative 2 is the term, not 2. That's why we talk about the terms being parts of an addition. You need to think about this quadratic here, this three-term expression, as an addition. So you'd have to convert this minus 2 to plus negative 2 to get the terms out of that. Well, mono means single, and this meal, I guess, is another thing of a term or a part. So mono is a single term, poly means many, so you have multiple terms. So they give us a lot of examples here: 7t, 2l, 2w, 5x cubed, y, 7/3 a to the fifth, and so on. These are all examples of polynomials. Even though there's multiple things in here, these things are multiplied together, so they're still a single term. Where these are polynomials because there's an addition occurring here. Okay, so and we'll talk about this fractional stuff too in a little bit. So it looks like they can create these, figure that they're a polynomial or a monomial. But like here, there's an addition, but the terms of this one would be, again, we're going to go through this, and they go through this too here, right, in this example. But you need to think of these in terms as parts of an addition. So they talk about that here. 4x minus 7 is really 4x plus negative 7. So the terms would be 4x and negative 7. And that's what the first example, some of the first problems you do in your homework are just identifying the terms of a polynomial. Nice little chart here of all the examples you can have. And there's some special names for the ones that we run into a lot. And so they'll have specific names for them. Mono means single term, so these are all single term. Binomials, bi means two in Latin, so we have two terms, and tri means three terms. And then if we have more than three, there's really no special name. They talk about divisions of expressions here. Really, it's when there's a variable in the denominator or the divisor of something, then we do not have a polynomial. It doesn't work like what we're going to deal with in polynomials. So they just bring these out. These are not polynomials. Notice we got, this looks like a polynomial term of negative 2x squared, and then you got this 1 over x. So we got division by the variable. This is not a polynomial. Another couple terms, they talk about degree, and degree is defined as the number of variable factors of the monomial. So thus the degree of 7t squared is 2, because 7t squared has variable factors. The variable in this case is t, exists as a factor twice. That's what the exponent of 2 means, okay? when there's only one variable, the degree of the exponent is of that variable. So they go through here. You got 8x to the fourth has a degree of 4, 3x has a degree of 1, and here's the one that's we haven't looked at for a while, but in the first section of this, first 3 chapters, they talked about what something to the 0 power means, and that's where they get this degree 0. Really, I could think of this as 7 times x to the 0 power, and then that would mean the factor of x, the variable x, is a factor 0 times, would be one way to think about that. The coefficient is the number that's times that variable. So in this example, it says identify the coefficient of each term in this polynomial. So coefficient again is the constant or numerical value times variables. So in this case, 4x cubed is 4, negative 7 is x squared is negative 7, and so on. Now they're going to talk about degrees of polynomials. So if we took the degrees off each term here, notice that they represent the terms as if they're parts of an addition. We end up with these terms: 3x squared, negative 8x cubed, 5x to the fourth, x 7x, and negative 6. The coefficients are listed here, and then the degree of each one of these terms is listed here. Okay. The leading term is 5x to the fourth, and the leading coefficient is 5. The degree of the polynomial is 4. They take the highest degree of the terms and use that for the polynomial. Then they talk about combining like terms. This is really using the distributive law, and I like the way they show this, is that because when we put things as an addition, we can use the properties of the commutative property and the associative property and do some things here that we're going to look at here in a little bit. But let's look at example A here first. 2x cubed plus 6x cubed. And they say, hey, we've identified a common variable term here of x cubed and x cubed. Using the distributive law, I could say this is the same as 2 plus 6, all times, or the quantity times x cubed. Well, now I can do this addition in the parentheses. I do order of operations, I get 8 times x cubed. This is the distributive law, or sometimes called factoring. We use it for factoring. And also they'll start talking about combining like terms, but it's really using the distributive property or law in this, how they say it. Well, let's look at this B right here, longer expression, nothing really more complicated other than understanding what we can do with like terms or how we can use the distributive property. Well, they have this, they have it all as subtraction. See, I would prefer that they would change it to an addition, because they're starting to change the order and you have to be careful with subtraction. Now they do it correctly, but probably what I would do is change all this subtractions here to addition by adding their opposites. So I would probably rewrite this as 5x squared plus 7 plus 2x to the fourth plus a negative 6x squared, change that subtraction, plus negative 11 plus negative 2x to the fourth. Now it's all addition, so I can change the order. And how do I change the order? I want to match up the places where the variable degrees are the same and the variable base are the same, or the exponent and base are the same, because that allows me to use the distributive property. So we've assorted this out in a specific way. And really what it's like is grouping this 5x squared plus a negative 6x squared. I group those, so I'm going to deal with those together. That's the associative property. And I'd group these two here, 2x to the fourth plus a negative 2x to the fourth. And I group those together, and then I can group the 7 and plus a negative 11 together too. So they take a lot of leeway here with changing order without changing to an addition. I would change to an addition. You're going to make a lot less errors if you do that too. Well, now with the distributive property, I can get the coefficients basically away from the variable, and then I can actually do operations. And that's the goal of this, is to use the distributive to be able to find a way to perform operations and basically bypass order of operations. In this form, I can't do anything with these two things here in this addition until I deal with the multiplication, unless I have a law that allows me to override that order of operation, in this case the distributive law, and in distributive law here. And then this is just associative, putting these two together. Well, we end up with a negative 1x squared, that's 5 minus 6, or 5 plus a negative 6, negative 1 times x squared, plus 0 times x to the fourth, plus negative 4. Well, 0 times anything is 0. And it does say you can do these steps mentally, which is absolutely true, but it's very key that you understand why you can do this stuff. We're going to use the distributive law a lot of different ways. This is one of the big ways we do that. So we end up with this expression simplified. They take the negative 1 and just make that a negative x squared. Negative 1 times anything is like the opposite of, or the negative of. Of means multiplication, right? And then they change this plus negative 4 back to minus, back to a subtraction of 4. So they're going to go through this even with fractions. It's pretty much the same, only we're just adding or subtracting fractions. If you did it my way, you'd only add fractions. So the other thing too is they say followed by the highest term. Usually we write polynomials in a descending order, so we start with the highest term, the highest degree term, first, and then go down in order. And then they go into, if we have these polynomials, we can evaluate them. So if I have this polynomial of negative x squared plus 3x plus 9, first I would look, is there anything I can do to combine like terms or add these things? Is there any way to simplify this expression? In this case, there's not. And so then I go in here and I just want to replace the x with negative 2. A very good way to do this, especially when we're dealing with exponents and negatives and stuff like that, is just put parentheses for your slot for the variable. So like I have this, notice just they put parentheses around it, and they put, for the x they put negative 2 in, and for the x here they put negative 2 in. Now remember, order of operations is I need to do exponents first. I don't want to take the negative of negative 2 first. That's really a multiplication that's going on here. I can't multiply till the exponents are taken care of. That's order of operations. So first I take negative 2 to the 2 power, which is 4, and I end up with this new expression here. So I get the negative of 4 plus 3 times negative 2 plus 9, and then they show the results of the multiplications, right? Remember, this negative is like negative 1 times 4. So then I can add, in this case they add the negatives first to get negative 10 plus 9, which is negative 1. So the same thing when we're just taking, in this case, more complex polynomials, and if they tell us that they want to evaluate for when x is equal to 10, that means I put 10 in for the x's here. Remember, again, just putting it in as if there's a grouping symbol around, and then make sure your exponents are right and your multiplications are right. Order of operations, big deal. Some more examples with graphing. There's a little deal a lot of times when we have graphing and then your homework and stuff. There's some tables in this homework assignment. Remember, what a term is, coefficient, degree of the term, and degree of the polynomial. So they give you a polynomial, and here's a whole chart of this that you need to fill in. Okay, and I'm pretty sure your assignments are pretty close to that. I'm still getting some questions about proctoring for the Chapter 4 test. That's why I give so much time ahead, and we're going to be pretty set on the schedule so we can make sure that you get your proctoring. I've reserved a proctor in a room at the Wenatchee College. It's in the announcements. There are computers in that room, so you'll be able to log into your My Math Labs the way you do for your homework and your quizzes. And then the proctor will make sure you only use the materials that are allowed, which almost always in these chapter tests will just be scratch paper and a Texas Instrument 30 calculator or equivalent. I don't want any phones used as calculators or graphing calculators, because you can program answers into those things. So that's what the proctor will know, that you'll have to have that. A lot of times we'll provide some calculators if you've been using your phone, or a higher level calculator. We'll try to have some calculators available in that room. But if you're arranging your own proctoring, you need to have come in with the right tools. So you want to come in with a pencil or pen, a lot of scratch paper, and one of those types of calculators.